multiplication of polynomials. So in this video we are going to learn the process of multiplying two polynomials and to find their product. Okay, so the first thing is you'll use distributive property. Using distributive property you can find the product of those two binomials. So here I'll give you an example of the distributive property. Suppose if I have a plus b multiplied with c plus d. So what happens is a multiplies with actually c plus d. That is a times c plus d, right? Second expression fully I copied. Plus b is there, I'll write plus b times again this whole expression c plus d. So now use the distributive property, a monomial with the binomial. A times c, ac, plus a times d, ad, plus b times c, bc, plus b times c, bd. Right? These are the four expressions you'll get. Like we can also say first with first, first, and the first multiplies with the second here. First, that AC, first and the second AD. Now the second with the first, BC, and then second to second BD. That we can also say FOIL, the FOIL method. The first terms, then the outer terms, then you have the inner terms, and the last terms. First, outer, inner, and last. Okay, and I'm also going to show you the area model, which is I think easiest compared to the distributive property. Okay, so first let us show you this traditional distributive property. I'll take this 2x, multiply with the whole of 3x minus 8. Okay, so then I'll have to do same thing with the 5 and 3x minus 8. So let us do one thing at a time. I'll take 2x multiplied with 3x minus 8. Then plus 5, this 5 multiplied with this 5 multiplied with again 3x minus 8. Alright, so this is 8. I have two expressions now, 2x times 3x minus 8, again 5 times 3x minus 8, and I am applying distributive property individually on those two. So how do you do that? Like we did in the previous video, 2x times 3x. 2x times 3x, again 2x times negative 8, right? 2x times 3x and 2x times negative 8 plus 5 times 3x, 5 and 3x, 5 times 3x. Now you see here plus and minus becomes a negative. Okay, I can show it in the next step. Plus 5, this plus 5 times negative 8. Alright, you all got it. So this one 2x and 3x, 2x and 8, then 5 and 3x, 5 and 8. Let us find those products. This is 2 times 3. 2 times 3 is what? 6, x and x, x squared, 6x squared. Alright, and then this was a plus 2, I didn't write a plus here, plus 2x times negative 8. Positive times negative, that's a minus sign, so you could have written minus at the beginning also, but still it is plus times minus is a minus, and 2 times negative, 2 times 8 here, because already I got the negative sign into consideration. So 2 times 8 is 16 and then x. Then you have 5 times 3x, 5 times 3, that is 15 and x. No trouble with the positive negative sign here because both are positive. Lastly, plus 5 minus 8. Positive times negative. Negative 5 times 8, that is 40. Right? So we are almost done. Now I have only 6x square by itself. This 6x square is there by itself, but minus 16x plus 15x, those two are the like terms, x and x terms you have. So I can combine those two together. Minus 16x plus 15x will give us, from 16, 15 gone. So you'll just get 1, that one, and that is an x. So, and 16 has a negative sign, bigger term has a negative. I'll write minus 1x. Or you can just say it is negative x. X is 1x only, right? Minus 40. That is my answer. That is the product of these two binomials. Okay. So for some reason, if this didn't click you, so let me show the same thing using the area model. Okay. So we have here all right. I'll just draw one big square here, then lines, and I'll copy this expression. Let me take it. Okay, you can write any of this expression. I can write 2x plus 5 on the top or on this way, horizontal. So let us just write it down here. That is 2x plus 5. On the top I'm writing, I'm giving this space for 2x and the next for 5. Then this is for 3x and minus 8. And let us fill in the boxes with these terms. Okay, so I'll have this 3x times 2x. In this case, 3x times 2x. In the previous distributive property, if you remember, we did 2x times 3x. It is just the same commutative property. 2 times 3 is 6, or 3 times 2 also 6 only. Okay, so here I got, in the first box, I filled in with this 3x and 2x. So let me show it to you with the highlighter. Okay, so this and that way there you go. And the next one goes like this. Okay, let me hold on to that. So next 3x with 5, that comes up here. 3x times 5. You filled in the second box. Now to fill in the third box, 2x is there already here, but 8 has to go there. So let me handle it here, this way. Alright, so negative 8 came here, and 2x. So that fills in here. Negative 8 times 2x and negative 8 times plus 5. Negative 8 times a positive 5. Right, these are all multiplications. Now complete that multiplication thing. So 3x times 2x, 3 times 2. How much? 6. X and x, x is square. 3x times 2x is 6x square. Similarly here, 3x times 5x. 3 times 5, 15, and there is a x. And in the third box, negative 8 times 2. Negative 8 times 2. Negative 16x. And in the fourth box, you have negative 8 times positive 5. Gives you 40. Right? So we got 4 terms, like the first, that outer, inner, and the last. All the 4 boxes is simplified and put them all together, starting from the first. 6x square plus 15x, then minus 6x. I am taking these things. 6x square, 15x, minus 16x, and minus 40. minus 16x minus 40. This is 6x square plus 15x minus 16x will give us a negative 16x minus 40. That is the product of these two. 2x plus 5 times 3x minus 8 gives us this answer, right? And see, is it the same thing in the distributive property? 6x square, oh I missed that x square here, 6x square minus x minus 40. This same answer you have up here. In this area model also, you have the same thing, right? 6x square minus x minus 40. So multiplication is done like this. Either you have it in these boxes, write on the top two terms and on the side two terms and fill in all the boxes and simplify, or directly use your distributive property and simplify, whichever is convenient. And I have a problem here for you. You can try this one. All right. Okay. Thank you.